All right, so 1.1, radical expressions rationalizing denominators. So let's start with the definition of rational number. So rational number is a number that can be expressed as a fraction containing integers. Any number that you can represent with a fraction, right? Let's say 1/3 or 5/2. Okay, any number that can be represented by a fraction is called a rational number. What is irrational number? If you have, let's say, square root of 2 or pi, right? Those numbers cannot be represented with a fraction, so they are called irrational numbers. So what is rationalizing the denominator? So the process of changing a denominator from a radical square root to a rational number integer. So we want denominator to be an integer. So why? Dividing by an integer is preferable to dividing by a radical number. Okay. So now we have these questions. Again, you already know how to do such questions. Let's say if you have -2/5√3, so to rationalize this denominator, so you see √3, right? You multiply top and bottom by √3. Then this gives you -2√3, and then you have 5, and √3 times √3 gives you 3. So you end up with -2√3/50. So we have B, 4/3√2 plus 8. So we want to rationalize that. Again, we did such questions in advanced functions when we did trigonometry units. Okay, so what you do to rationalize that? So it is not going to help if you multiply top and bottom by √2, okay, to rationalize this. So what do? We look at this denominator, find the conjugate, and then multiply top and bottom by that conjugate. So what is a conjugate? Okay, so you see at the bottom, if you have, let's say, √a minus √b, so the conjugate of it is √a plus √b. Or if you have √a plus √b, √a minus √b would be the conjugate. So these two are conjugates. So first, so we have two terms, right? You keep those two terms, but if you have a plus, then the conjugate will be with the minus. If you have minus, the conjugate will be with the plus. All right. So 4/3√2 plus 8. Then the conjugate is 3√2 minus 8. And we multiply top and bottom by that. Okay. So now distribute 12√2 minus 32 over. For denominator now, when you multiply with the conjugate, you create difference of squares. So you get 3√2 square minus 8 square. 3√2 square, 3 square is 9. √2 square is 2. So 9 times 2 is 18. And 8 square is 64. Okay. So 18 minus 64 is 46, -46. But you are not done because this can be simplified further. When you look at 12, 32, and 46, they all can be divided by 2. Okay, so factor 2 from the numerator. So that gives you 6√2 minus 30 minus 16 over -46 Okay, then when you simplify 2 and 46, you get negative 23. And we don't leave the denominator with a negative sign. So now you need to move negative sign to up, means you multiply all the terms by negative 1. So that gives you then negative 6 root 2 plus 16 over 23 is the final answer. Okay, now we have C. We have root 27 plus root 24 over root 27 minus root 24. We are trying to rationalize denominator. So we look at the denominator, then find the conjugate, which is root 27 plus root 24. Multiply top and bottom by that. Then in numerator, we have root 27 plus root 24 square, right? Let me do that on a different piece of paper. So basically we have root 27 plus root 24 square for numerator. The shortcut for a plus b square is a square plus 2ab plus b square. I'm going to use this shortcut. Square of the first term is 27 plus 2 times root 27 times root 24 plus square of square root of 24 is 24. So we get 51 plus 2 times. So, well, you need to multiply these two, but check if you can simplify these radicals first. Root 27 can be written as root 9 times 3, and that will give you 3 root 3. Root 24 can be written as root 4 times 6, and that gives you 2 root 6. 2 root 6. So what do we have here? 2 times 3 times 2. 2 times 3 is 6. 6 times 2 is 12. Root 3 times 6 is 18. You can even simplify this further. So 18 is 9 times 2, right? Root 18 is root 9 times 2, which gives you 3 root 2. So we have 51 plus 12, 3 root 2, which is 36 root 2 here. That is the numerator. So numerator is 51 plus 36 root 2. Denominator, again, we created difference of squares here. So then we get root 27 square minus root 24 square. Okay, so we get 51 plus 36 root 2 over 3. And finally, again, when you look at 51, 36, and 3, all are divisible by 3. The factor 3, 51 divided by 3 gives you 17. Plus 36 divided by 3 is 12. Okay, so 3 and 3 is gone. So 17 plus 12 root 2 is the answer. Okay. So in certain situations, it is useful to rationalize the numerator. Okay. Again, this is for the purpose of calculating the limits, which we will do later. Okay. So this time, for example 2, we are going to rationalize the numerator, not the denominator. So a, root 10 minus root 6 over 2. Numerator is root 10 minus root 6. Conjugate root 10 plus root 6 over root 10 plus root 6. So multiply top and bottom by the conjugate. Okay, so now we created difference of squares for numerator, not denominator. That gives us 10 minus 6 over 2 times root 10 plus root 6. 10 minus 6 is 4 over 2 root 10 plus root 6. 4 and 2 can be simplified. 2 over root 10 plus root 6. Okay, so we now rationalize the numerator. And denominator is with radicals. That's fine because the question is again asking only for rationalizing the numerator. So next one. We have root y plus 6 minus root 6 over y. Conjugate of numerator is root y plus 6 plus root 6. And we multiply the denominator by the same thing. So what do we get? Root y plus 6 square, which is y plus 6 minus root 6 square is 6 over y times root y plus 6 plus root 6. So this gives you then y over y times root y plus 6 plus root 6. Now simplify y and y. You get 1 over root y plus 6 plus root 6. Part C, we have square root of 2x minus 4 over 8 minus x. Again, we are rationalizing the numerator. Therefore, we need the conjugate of the numerator. So then we get root 2x plus 4 over root 2x plus 4. This gives us root 2x square, which is 2x, minus 4 square, 16. And in denominator, we have 8 minus x times square root of 2x plus 4. Okay. So we can now, as you see, 2 is a common factor for numerator, so we can factor 2. Now I want you to notice something, right? 8 minus x, x minus 8. They are called opposites. Okay, so let's say you have 7 minus 2x and 2x minus 7. These are opposites, right? Or if you have y plus 6 and negative y minus 6, these are opposites, okay? Because see, if you multiply one of them by a negative sign, you get the other one, right? So as you see, 7, negative 2x, positive 2x. So it looks like when you multiply 7 minus 2x, you get 2x minus 7. So then what you can do, you can factor the negative sign here. so that it becomes x minus 8. Okay, so if I factor negative sign, I get x minus 8. Root 2x plus 4 is still here. Now x minus 8 can be simplified. So you get 2 over negative square root of 2x plus 4. Again, remember, we don't keep the negative sign in the denominator. Move it to the numerator. Multiply numerator by negative 1. So you get negative 2 over root 2x plus 4.